onto a couple of application problems. A rectangular solid has height, h, and a square base. One side of the square base is 8 inches longer than the height. Find an expression for the volume in terms of h. Might help to make a little sketch. So our base is here, and our height is here. Now, I don't like the phrasing here. One side of the square base, it's the one side that bothers me, because if it's a square, then both sides of the square base are 8 inches longer than the height. Okay, find an expression for the volume in terms of h. So it's just the base times the base times the height. And remember, they said the base was equal to 8 inches longer than the height. So height times base times one side of the square, h plus 8 times h plus 8. And there is our expression for the height. I believe you can just enter it. You don't have to simplify it. So you can just enter it as h times h plus 8 squared. That, to me, seems like the least amount of typing. Okay, so find the values of h in interval notation that makes sense for the volume. Well, look, the volume has to be greater than 0. And that's about all we can say about this. We don't know anything else about the base. So h could be just slightly greater than 0, and this would all work out. Interval notation, 0 to positive infinity. All right, next one is a classic problem. I'm hoping that you saw it in Algebra 2, because often I will do this problem. But I looked up a drawing on the internet and found this pretty conveniently. So we've got our original dimensions over here, and then it shows these x's cut out. And then if you cut out those x's and you fold the box up, you've got that on what we see on the right. Notice what they do, though. For the 17-inch side, on the other side, it's giving you the width in terms of x of the length of the folded up box. All right, so knowing that, our volume is, just like the previous problem, going to be the base, the two bases multiplied by the height, that is x. So our volume is our height x times our first base length times our second base length. And again, you can enter this just like it is. You don't have to do the multiplying. In fact, they ask you to not multiply. All right, what's a realistic range of values for x? Answer in interval notation. So here's the deal. X needs to be, it's got to be greater than 0, but it also can't be so big that when we subtract 2x from 11, we get a negative number. So that means that our limiting width here is going to be 11 minus 2x needs to be greater than 0. So if we solve this, we add 2x to both sides and then divide by 2, we'll get 11 halves. So x has to be, try that again. So add 2x, I get x, so that means x is going to be less than 11 halves. Okay? All right, what does that look like in interval notation? There's our 0, so our volume has to be, x has to be greater than 0, otherwise we don't have a box, to 11 halves. I'm pretty sure they'll accept a decimal. And that answer goes down here. And we are done. See you in class.